Go ahead, Izar.
So, as we said before, my name is Izar Tarandach. I am the principal security engineer at Squarespace, and I call it architect/engineer because basically I architect more than an engineer, but still doing the code thing. Have been doing the security thing since the 90s. Now I'm sort of like at peace of telling how long I've been doing this thing to people. But currently, I am focusing on modern SDLCs, meaning how do we integrate this whole thing into Agile and CI/CD and all that soup of letters that everybody is running around with these days. Matt.
And I'm Matt Coles. I am, I'm technically an engineer, but I do a lot more architecture and leadership and strategy work with the teams that I work with. Primarily in industrial and consumer IoT devices, as well as connected systems, devices and ecosystems, as I like to call it. Right, you protecting a device is one thing, and so I do product security specifically, and I do physical device product security as a very specific thing. I leave that cloud stuff to other people. That's just weird. We need an ecosystem to run it all, which gets me back into the cloud stuff again. We'll just put the disclaimer out here first that we're talking for ourselves and not our employers. We work at places. We don't speak on their behalf. And as you can see here, we've both been working together since 2010. Somebody asked earlier if we were both with Dell. We were both with EMC, which was pre-Dell. We both worked in what was called the Product Security Office at that time. And let's just say we made friends and frenemies and enemies along the way. And now I'm back to deal with those same people.
Good times.
Good times.
Good times were had by everybody.
We both we're co-authors of this thing. Hopefully you can see that. He has a picture of it. That's mine apparently is flipped on the video.
We see it right.
Oh, you do? Okay, good. And so we wrote this little book. We've both been interested in doing. We both had been doing teaching and helping people learn about threat modeling and other things over the years, and we decided to put a book out. Oh my God.
And one important note about the book, we wrote it mostly for development teams, for engineers, for people who actually sit down and write code, and less for the security practitioner who, if they call it themselves, they should already know this stuff. So the important thing here is that it's the kind of book, it's short, it's like 200 pages or something like that. It's the kind of book that we want people to buy in like huge boxes. O'Reilly has amazing discounts. And
it's thin, as you can see, nice and thin.
Just hand it to their developers and say, hey, today's Friday, here's a book for you. Come back Monday knowing everything there is to know on how to do a threat model. And actually, we had a number of user feedback, let's call it like this. And it's doable. It's totally doable. And you can even like get a nap in between the chapters. It's doable. So if you have a lot of developers, you want them to know everything about threat modeling, this is the thing that you want to give them. Not all of those more security-oriented books that are out there that are lovely books. We love them. We read them. We cite them, but we are not them. We try to be for developers.
And also, as you can see here, we were both members of the Threat Modeling Manifesto working group. We'll get into more details about the manifesto in a few slides, so we won't talk about it much here, but that was a fun and exciting collaboration. And there's more than what's listed here, obviously, over the years. So
before we begin, on the bottom, you guys have the raise hand button. If you don't, it means that you haven't updated your client in a while. So click on it, please. If you consider yourself a technical security practitioner, and by technical, I mean you get down into design, you get down with the engineers, and you are able to carry a dialogue at that level. Go for it. Okay, we have one person, Shaya. we usually ask this just to calibrate where we're going to be with the stuff that we are presenting. We got more slides than we probably are going to reach, and we just like to have a feel for what people are actually interested in. Matt, take it away.
All right. So our agenda today, we're going to talk about some relationships in security. We'll talk about the manifesto, and as Izar was just talking about, if we, if the desire is there and the time is there, we'll talk about some other more deep technical things. As I mentioned earlier, we do like these presentations to be interactive, but for privacy and other reasons, if folks feel they need to ask the questions after the recording or want to do it more anonymously or through the chat or whatever, just let us know or tag it in the chat or something, and we'll address it as best we can. So.
And I would say if you do want it to be anonymous, put it in the chat, because the chat won't be part of the video, and that way you can answer it without mentioning names, maybe.
Yeah, we when we read from the chat, we won't mention names. Okay, so let's talk about some relationships. So when we think about a system, we think about a system that has certain things, right? So first off, it has two really important things, right? It has data and has functionality, right? Every system has one or more of these things, and some systems have a lot of these things, right? Have a lot of data, for instance, or a lot of stuff that it does, functionality. And when it comes to security, what we want is, and for folks who are not in the security space today, or are new to the security space, this may be, some of these concepts will be new. For those who have had some experience, maybe just a refresher. So of course, we want to maintain certain security properties, right? So we want to make sure that our data remains confidential, right? We want to make sure that it stays, that can't be accessed by somebody inappropriately, so that they can't, take the data or view it. If we have financial records, for instance, or personal information, we don't want that information to be viewed by an unauthorized party, right? So we want to maintain data confidentiality. We also want to maintain integrity and availability. Sorry, the slide is taking a while to flesh out here. We want to maintain integrity and availability of both our data and our functionality, right? So in addition to having the data be available for somebody who's authorized to view it, we want it to be not tampered with. Likewise, we want our functionality to be present and be available for those who have a legitimate need for it or a legitimate access to it, and that functionality hasn't been modified. So these are some of the core security properties that we're going to look for, especially when we're doing threat modeling. Now, this holds for not just security, but also for privacy, with slightly different variations on these three core principles, as well as potentially safety, right? We're not going to talk about those in particular today, but suffice it to say that these things, these things go together, and so if we can protect a system with security, we can likewise do it for privacy and for safety. So I don't want to leave those out of the stool. I just want to say that we're not covering it in the slide. So how do we go about protecting confidentiality, integrity, and availability? So first off, we look at a set of controls. And some of those controls we want to apply are pretty basic to help us identify that the first core thing that I mentioned when we talked about confidentiality especially was making sure that data is accessible to those who are authorized to have access, right? So we need to be able to establish that authorization context. We need to establish who's authorized and who isn't, so we can make a decision, right? So we want to be able to say, who are you? Prove it with authentication, and now we can make an authorization decision. Once we make that decision, or in the process of making that decision, we want to keep good records so that we can go back later and identify if anything nefarious occurred. We also will start applying patterns to our systems. So common patterns that we use in security to protect these properties are defense in depth, right? You don't build a house with only one. If you build a house and it has more than one entrance, you're going to put more than one door in place, but you're definitely going to put locks on your windows too, right? We want to also look at, as another pattern, least privilege. So this is a common thing with especially applications that run on top of an operating system. And my apologies, my dog is probably going to bark in the background here, so hopefully not too loud. So we want to make sure that these privileges maintained. That means that a process or an application or something that's executing only runs with the least amount of privilege that it requires. So a common problem that happens in systems is everything runs as root, and that's bad, or can be bad. Another pattern that we want to make sure that gets enforced, or at least is present in the system, is that things fail securely, right? So if if we're making an authorization decision and the system that we're using to decide those rules goes away, what should we do? Should we let everybody in? Oh, no rules today. You can let everybody in. But no, we really want to fail secure and say, oh, there's no rules available, so we have to assume the worst. Sorry, right? And that's something that, that's a pattern that we might use. And last pattern here is complete mediation. So wherever we do these authorization checks, wherever we do these controls, we want to make sure that they're done consistently across the application. And lastly, we want to make sure that there's a set of capabilities that are present in the system, right, to ensure security. Common things that we're going to put in this toolbox: encryption and hashing, right? So we want to be able to protect data, again, for confidentiality as well as integrity, especially. Those two things go hand in hand with encryption and hashing. We also want to, in order to make a good path to our authorization check, that we have complexity checks in place to make sure that we have strong credentials, for instance. And that, lastly, that we have things like execution prevention, so we make sure that only those things that need to execute are executed and everything else doesn't get run. So it's these set of controls, these patterns, and these capabilities that enable us to enforce the security properties of confidentiality, integrity, and availability. And likewise, if we were doing privacy, around repudiation and whatnot. So the reason for calling these out, of course, is this is what we're doing when we do threat modeling, right? We're looking for where do we have potential violations of these basic properties, and where do we have or not have these controls on patterns and capabilities that help us maintain those properties, right? And that's what threat modeling is all about. And obviously, this is not a complete list. This is just a handful of things that we look for, but these are some pretty common ones. So when we look at the relationships of things here, the other core thing we need to understand is the relationship between our system and the landscape of security. And so there's some business stuff here as well. So first off, we have a system and it has data and functionality, right? And that gets us value, right? That's what we get, some value from that data or from that functionality, right? We put out a piece of software, and let's say everything ranging from an open source component that we get value because somebody makes use of it and finds it interesting and finds it functional for their purpose, or we make money off of it because we're an enterprise, right? And this can range anywhere from a device all the way up to multi-system cloud environments with AI and ML and the whole works, right? Because that was mentioned earlier. Everything's going that way, right? And so we have a system that has value. And so as developers, as system developers and system designers, we make mistakes at times, right? And so we call these mistakes weaknesses. So weaknesses are the underlying bugs that result in the potential for a security problem. And for those who aren't familiar, there's a whole database of weaknesses out there available from MITRE in terms of the common weakness enumeration. where all of the different types of vulnerabilities, all the different types of weaknesses that are potentially present in a system that can be introduced are classified. And there's a lot of good information that if you're not familiar with, you definitely should check that out. So we have these weaknesses. Now, in the case where a weakness is exploitable, then we call it a vulnerability. So a weakness, like a bug, like a buffer overflow, say, may or may not be exploitable. We call it a weakness until we know otherwise. As soon as we know that buffer overflow is exploitable, meaning it has some means of getting to it from the outside, then it becomes a vulnerability. If somebody can make use of it to cause some bad behavior, then it's a vulnerability. And what causes a bad behavior is a threat, right? And ultimately, this is the core thing of threat modeling, as we're leading up to. When we do threat modeling, we are looking for threats and modeling systems that help us identify weaknesses and vulnerabilities and threats. We'll also, along the way, potentially identify some threat actors. And these threat actors are those that use a threat to impact or to make use of a vulnerability that causes an impact to the system, which impacts our value, right? And it is this combination of the system's value and its threat, and the likelihood of that threat occurring, that drives risk. Okay? Now, just having this chain of an actor to a threat to a value to a risk does not necessarily to tell us what the risk is. There's other pieces that you need to know, right? So first off, how do we know that a threat actor is going to do something? Well, they have to have a means, right? They have to be able to take advantage of a threat and make use of vulnerability, make use of a vulnerability to cause an impact. They need to have a motive, right? They have to have a reason to do something. And they have to have an opportunity, right? If you don't give them access to your network, they're not going to be able to take advantage of that vulnerability, even if they know how to do it. But then lastly, they need the desire or the will to do it, right? Izar and I both are very good at our jobs, and we know how to take advantage of vulnerabilities, but we don't rob banks for a reason, right? And so, although apparently it'd be easy to rob a bank, but that's what I've heard.
No promises.
No promises. So you need to have a threat actor who has the means, motive, opportunity, and will. You have to have a threat, which is a way of influencing a vulnerability to cause some impact to a system that impacts value, and that drives risk. All right. So now let's talk a little bit about some threat modeling stuff. So what we have on the slide here is a traditional data flow diagram. So it's important to know that when you're doing threat modeling, you're going to generate models. Now, primarily when you do threat modeling, a model is going to be a graphical model, right? So we're going to draw out the system. And in this particular case, we have a system where we have an actor, we have a process, we have a complex process, and we have a data store. And then we have lines that go between them that indicate data flow, hence data flow diagram. This dotted line represents what's called a trust boundary, which is basically an indication to the person analyzing the model, because we're going to take this model and we're going to analyze it for threats, that process A and process B are not trustworthy amongst them, right? So basically A may trust B, and B may trust A, but there's really a boundary here to say these are separate systems and don't trust them across that boundary. And then lastly, we provide some annotated information so that we can describe what these things are. And then is this information that we're going to use to generate threats. So here's where we generally take a quick break to ask the audience to highlight, do you see anything wrong with this system? And if you can I guess you can use the chat. You can blur it out too, but probably easier if you use the chat, and if you so desire. Is there anything that you see wrong with this? Anything of concern?
Well, data store C is not encrypted. Process B runs privileged. Those things stood out.
Those are good callouts. There's a couple others here. Anyone?
The
Data
read
store
permissions
C.
on data.
Oh,
Go ahead.
sorry. Data store C is also allowing read-write to users group, and everyone it's giving write access, which is not good. And also it's XML based, which has its own issues.
Yep. Good call out. Anything else? There's one little esoteric one in here for those who may or may not be familiar with the database. I'll give you a hint. The issues in process B.
They didn't change the default port.
Well, what is that particular port used for?
Yeah, I wasn't familiar with that port.
Oracle?
It's Oracle database, unencrypted.
Yeah, I think Shaya said unencrypted.
So that means your
So
SQL
it's-
queries are exposed.
Yeah.
Good catch, Shia.
All right. So we just did a threat model. Yay. I mean, that's it, right? You build a model and you analyze the model looking for threats. And ultimately,
what about the user side of things? You just say authenticated, but is there a whole list of things in there you're just not going to get into? You know, zero trust and things like that. It's just not a fit.
so that's the nice thing about threat modeling. You can start with, you don't have to be, the nice thing about threat modeling is you can decide what your definition of complete is. So we could do significantly more than that, but just based on the model that we have here, the issues that were called out are sufficient, right? And maybe sufficient for a first pass of a development project, right? If you're going through an agile sprint and you get 2 weeks or something, and maybe this is the first pass of the system, this may be sufficient, right? The other I guess key part here is this is basically a threat model where we identified weaknesses and vulnerabilities. The last piece that we didn't really do is sort of, okay, so who cares? We don't generally get involved with, and when we do threat modeling, we generally don't get involved with which adversary is going to attack a system, but more so who can do it, like what type of effort does it take, and what's their goal, right? And so, if somebody attacks process B, they're going to get access to the database. The database doesn't have to be read, write in order for that to occur, right? So what skill level is required? What's the attack vector? And what's the goal of attacking B, right? Versus, is somebody going to go after the data store and just steal the hard drive, right? Izar? Oh, you're responding to A. Okay.
Yep.
Responding to that. Okay. Yeah. So that's the sort of the next piece of threat modeling that we didn't really get into, but this is almost sufficient for, and actually really is sufficient for this activity where we look at a design of a system and identify some obvious concerns, right? In the next slide, in this slide, I'm going to take that same model and change it in absolutely no way other than the shapes that we use. So the traditional threat model, the traditional DFD uses these round circles and double circles and these parallel lines and these curved arrows and trust boundary and everything. In what's called DFD3, which is an evolving standard, well, I should say it's an evolving proposal, not necessarily industry standard, but it's a proposal for how threat modeling and DFDs might be done in the future, where we use this more simplified shape pattern. So we have an external entity, in this particular case, still the user. We have rounded rectangles as our processes, we no longer call out which one's a simple one and which one's a complex one, other than through notes. And then we have a data store, which looks a little bit more like a database, and actually is a little bit easier to get out of a standard stencil, because you can get this out of flowcharts and not have to create your own parallel lines. To establish a trust boundary, we draw these dotted rectangle, and data flows are represented by arrows, either unidirectional or bidirectional, depending on the direction and scope of travel. And this makes a much cleaner system diagram, has the exact same properties. And then lastly, you can use a sequence diagram to do the exact same thing. The sequence diagram provides us with almost as much information with respect to the data flow diagram, and more, because we now get sequential information. We now get not only that the user talks to A to do something, but the user talks to A and it gets a response, and then it talks again to A, and then A sends something to B. So we don't get just the data flow, but we also now get the interaction flow, which we don't get in the data flow. And so to some extent, the sequence diagram is going to be more useful for threat modeling for certain things, right? There's certain things that we can get only out of sequence diagrams that we can't get out of a traditional data flow. For instance, when we talk about particular weaknesses around time of check, time of use is a fun one, right? How do you know that something is going to be out of date when you go to use it, and therefore have a time of check versus time of use issue? Well, you can't know it from a data flow diagram, because you only know that A talks to B, but you don't know in what order that occurs. And the sequence diagram will tell you that. So here's the exact same system, just drawn a different way. So that's the modeling side. So the sequence diagram, to answer the question that was asked on chat, the sequence diagrams are in our book. They are talked about in various places, not just our book, I think, but also I think the manifesto does not have any guidance on it at the moment, although that is something we've been working to update. And but you'll find sequence diagrams very common in development spaces anyway. So most development teams will almost always have sequence diagrams, and you can use those sequence diagrams to drive threat modeling activities, which is really the key part, right? So DFDs are generally foreign to developers, but sequence diagrams are almost always present when you're designing a system. And so if you have nothing else, or if you want to start with what you have, start with the sequence diagrams. We do talk about those. We do talk about other methodologies, other diagramming types in the book as well, just to cover those other pieces. So modeling is the first part, analysis is the second part. And so what we want to call out here, and I'm going to just build out the slide actually. So first off, here's a sampling of, there's something like 30 or so defined methodologies for threat modeling, but here's 3. We just picked 3 at random. And we chose 3 in particular, these 3 in particular, because they are all model based. So these sort of rely on having a model that you're working from to do the threat model analysis piece. So we have Stride, which is a security focused analysis process. We have Linden, which is a privacy focused process. And then we have continuous threat modeling, which is really geared towards operating in an agile environment, based on a set of if this then that based lists and information that you can apply to the model as you build it. And basically, the goal there in particular is to threat model against the stories that you use to build the system. When you look at especially security relevant or function changing stories. Going back to Stride really briefly here. So Stride, as mentioned, is security focused. It covers 6 threats, as you can see here: spoofing, tampering, repudiation, information disclosure, denial of service, and escalation of privilege. remember back to one of the earlier slides around the properties and principles and the controls that we were looking at? These are all violations of those things, and that's what Stride looks for. Looking at the privacy side, we have Linden, which takes the same acronym approach that Stride does. Now it looks for a different set of concerns that are privacy-centric. And then CTM is primarily security-focused, but could, in theory, be used for privacy and other use cases. Compare those three to something like TARA, which is threat assessment and remediation analysis, which is not model-based, but it's spreadsheet-based. And boy, is it spreadsheet-based. If you like Excel, you'll love TARA. If you don't like Excel, not so much. It's based on adversaries and assets and tactics. It has a set of catalogs that you use. It is excellent for what it does, which is really to get the best security capability of a system that is, especially for automotive or aviation, or where functional safety is of concern, or when mission resiliency is one of your core things. TARA is one of the better choices in that respect. But all of these have their applications, and their pros and cons, and those who prefer it versus not. But these are we're just highlighting that there are basically a plethora of ways that you can do threat modeling, and none of them are wrong. They're just wrong if you don't have any value. And I'm going to talk about that in just a couple minutes. All right, before we jump into that next slide, though, just want to catch up. Is there any questions folks have so far that we can chat about, or anything that we don't have answered on the chat currently? I don't think so. And sorry, do threat models vary by industry and region? So they will vary in term. I'm not sure about region. I don't have any experience there. But the models will vary in complexity and completeness. Let's put it that way, right? So TARA is very complete when you build the spreadsheet. It's very complete because it's meant to be very, very pedantic. You want to look at everything to make sure you don't miss something, because if you're building a spaceship or you're building a car that's going to have people in it, you want to make sure that you cover everything. Whereas something like Stride, you might be a little bit more flexible and fluid with the models that you build and the analysis that you do, because maybe you're not need to be as robust, right? And so it's going to depend on your use case, and with not only which methodology you apply, but also what your use case is, to decide how complex, how complete, and sort of what you need this to look like is. As for region, I don't think that's a factor.
Actually, I have some data on that.
Okay.
Some of the methodologies, like TARA, for example. TARA likes to take you by the hand. They have this 1, 2, 3, 4, 5, do these things in sequence, and you get them done. And as Matt said, it applies better to some cases and some industries, let's say, where you have a bit more of rigor in the design, and you start with a set design and you end with the product that was designed. Now, things like Stride and CTM, they try to be more flexible, and even, especially CTM, grow together with the product as the design happens. As they do that, they are more open-ended. The modeling part is fine. The elicitation of the threats becomes a bit problematic, because it becomes a function of how much security does the team know. Do they have a security person attached to them that can raise the level of that elicitation? And what's their level of comfort with the definition of done? And in observation, I have seen that teams tend to react to this freedom or to this dynamic approach in different ways depending on their culture. So you could say that, for example, a team in China, due to the culture over there, and a team in, say, Israel, they might use exactly the same methodology and end up with vastly different results, simply because of the way the local culture leads the process of inquiring, right? And I think that there's no stereotype here. It's just the fact that some cultures react differently to the open question of what could possibly go wrong. Okay, so that's where I've seen region reflected into it. But as teams tend to mix, tend to reach diversity, and tend to interconnect and cross-pollinate, we see that after some time, these things level up and everybody goes to the same level of results.
Excellent. Thanks for that, Izar. That's great. Okay. I'm going to pass it to Izar.
Yeah, yay. So the Threat Modeling Manifesto. We spoke about it, and now we're going to tell you all about it. Just so you guys can have an idea, I have it on my wall. A set of posters was made with the manifesto itself. Now let's talk about what this thing's actually made of. So we had this 15 experienced threat modeling practitioners, people from all industries, people with a lot of experience. For example, you got Adam Shostak, who is known as the guru of threat modeling. You got Brooke Schoenfeld, who has more than 40 years of experience doing this thing. You got Stephen DeVries, Fraser, who are people who are in the industry of threat modeling, creating commercial threat model tools, and people like Irene Michlin and Kim Witz, who are academic researchers in the area of threat modeling, and Matt and I, who just showed up because they needed 15 people. And what happened there was for like 6 months, we met once a week, and we started from a blank sheet of paper saying, okay, everybody's been talking about this threat modeling thing, but does anybody actually know what it is? Like, do we have a definition for this thing? Do we know why we do it? Do we know why it's good to do it? Is it good to do it? So we started asking all these questions and talking about the the answers. And actually, it was the best group effort that I have ever done in my life. It was simply amazing. And what happened there was that we came out with first a definition that not everybody needs to use, but that at least everybody can agree is a starting point, and a set of values, a set of patterns and anti-patterns that we're going to show you guys. And while it's not a technical approach to threat modeling, it helps in many different levels to direct the activity. So you could use the manifesto to go to a C board and say, hey, here's why we have to invest time and money into doing this thing. Here's why these things are important to us. Here's the value that we're going to get out of it, right? And you can go to a team and say, hey, guys, if you're going to do threat model, listen, don't care which methodology you use. You find the one that's best for you. But here are those things that you should be avoiding. Doesn't matter which methodology you're going to do, so on and so forth. So let's go and take a look at the details.
Well, before we do that, if you want to learn about how we went about and the approach of doing threat modeling, there are links here. These are podcasts that we actually recorded our sessions, our working group sessions, and put together a two-parter, I guess, highlight reel of some of the discussions that went into the manifesto, so that folks can understand our thought process, right? How we reached collectively as a team, how we reached the results, the outcome of the manifesto and all of its information, and some of the debates we had, because some of the stuff was pretty esoteric and some of the stuff was pretty, down to earth when it comes to, is anybody going to use this, and is this valuable, and this is hard, right? And or not, and that's we did. We recorded. It was kind of cool, actually, to have that happen. We worked well as a team. How do you pull 15 experts together and get them all to agree? So,
So if
It's
you're not,
called
if
herding
you're not
cats.
interested in threat modeling, but you're interested in how to get, in seeing an example of a really fruitful conversation and discussion and agreement, it's worth the time.
So yeah, if you could either post those links in the chat.
Yep,
or,
I'll work on that while we're chatting.
Perfect.
While we're
Okay.
talking.
So that famous definition that we got to. Threat modeling is analyzing representations of a system to highlight concerns about security and privacy characteristics. So welcome. Now you know what threat modeling is all about. We can go. But basically, for a long time, there was a discussion on what is this threat modeling, because some people thought that it was creating the model. Some people thought that it was eliciting the threats. Some people thought that it was clicking a button in a tool and getting something, right? And it started becoming something like the famous story of the three blind men trying to figure out what an elephant is. Every one of them touched a different part of the elephant, and therefore each one of them thought that the elephant was a completely different thing. And for the last 2-3 years, threat modeling started going up in profile. You can see on the security conferences, it takes much more time in the agenda. And people are people are in the middle of getting interested on why this thing exists and what it can do for me. So by focusing on the analyzing representations, we think that we sort of zeroed into the fact that it's a two-part process. You are trying to represent your model, and then you are going to analyze that representation to elicit the threats. Okay, next. So at the end of the day, there are these 4 questions here that we are trying to answer. And they are in order. What are we working on? It helps if you know what is it that you're trying to build, right? Sometimes even you start not knowing that, but the journey of figuring out will help you anyway. So once you know what is it that you are working on, then you jump to the next step. What could possibly go wrong? Now, here's where people have the most fun in my experience, because, and I'm just really describing my personal experience, I started with teams that looked at me and said, nothing can go wrong. We do everything perfectly around here. And then it takes like 2 or 3 minutes to disabuse them of the notion. I haven't made anybody cry, but I'm still trying. I'm still trying. And
I will admit I have.
once we figure out these things of what can go wrong in this thing that we're building, then we ask the next question. What are we going to do about it? So each one of those things that can go wrong, what can we change in the design? What can we create for the implementation? How can we test stuff? So you guys see that here I'm moving from threat modeling into the other stages of development, right? So this is the first time where I can say a threat model is an awesome thing to hang your SDLC on. So once you have a threat model, you can hang the whole process of secure development onto it, because you figured out what is it that you're building, you figured out those things that you want to protect against, right? And now you can use that as a recipe for your tests. You can use that as documentation for your pen testing. You can use that as a seed for creating requirements, right? But it all starts into that threat modeling process. And now 4, once everything is done, and we're going back to the everything is done later, we ask ourselves, did we do a good job? Because if there is one thing that is for sure in this process here, it's cyclic. You can get momentarily paused in your threat model efforts, but you are probably not done for 2 reasons. Your system keeps changing, and threats keep evolving. So if, I don't know, 20 years ago, we thought that buffer overflows were like the worst thing that could possibly happen to us, nowadays, hey, you know, we are trying to solve that little cross-site scripting thing and that little SQL injection thing for what, 10 years or so? And the numbers just keep going up. So we're doing something wrong. Anyway, that's a completely different rent. Now, Matt, next. How do we measure, did we do a good job? Oh,
Sorry, I was in the middle of typing the response. Yeah,
yeah.
so
there.
that goes into one of our first slides, right, where we talked about value of a system and threats and risks. And so, did we do a good enough job? Really is trying to decide whether we've made sufficient progress to eliminate or reduce the ability of a threat and a threat actor to influence a system and degrade its value, or said another way, to protect the value of the system. And we may not, and almost certainly will not, get it 100%. So when we are looking at, and especially since we are at the time we're doing threat modeling, for instance, we're talking about the design. We can build an architecture that we can identify threats, we can identify vulnerabilities or weaknesses in that architecture. But then we can only do so much about it. We then have to rely on later the developers to implement that architecture correctly and hope that they don't introduce additional concerns, right? So implementation flaws that degrade the value or the protective capability of the architecture. So did we do a good enough job? Well, it's subjective into the phase we're doing it. It is almost certainly not going to be perfect. And it becomes then a decision for the organization about, well, how much effort do you put in? Is it the classic risks discussion of how much do you spend versus how much protection do you need? And yes, it could be open-ended quest, meaning you could continue and going back and forth and spend money and find new issues and spend more money and find and fix new issues, or something. You're always going to miss something, so it becomes a risk management discussion as well as an organizational and team decision.
So that's one approach, and that's the formal approach and right approach, and it mostly focuses on the threat modeling itself. But remember when I said that it can use as a hanger for the rest of the process? So one measure of did you do it good enough could be, hey, I generated threats for my threat model, that generated requirements. How well did I fulfill those requirements? Do I have still security technical debt after looking at those requirements, and there's stuff that I'm pushing forward to other places? Or do the things that I found, the threats that I found and that I probably mitigated, did my tests actually cover the whole thing? Or do I have a problem with coverage? I don't have enough tests. So there is a lot of different things going from numbers to feelings. There's a whole spectrum in there that you can definitely look at. Some you can measure, others you have to sort of extrapolate a bit. Okay, so time. Great.
Yeah, in the interest of time, I'm going to skip this slide since you already talked about it.
We already mentioned it. Okay, values. Yay! We have how many? 5 values. Yeah, 5 values. So the first one is we are looking for a culture of finding and fixing design issues over checkbox compliance. Meaning, you could well do, and we have seen it done before, Matt and I, which generated a lot of scratching of the head and dismay. We have seen people threat model with a spreadsheet with a list of questions and answers of yes, no, yes, no, yes, no, yes, no.
Like Tara.
Yeah, but Tara is a bit more evolved, but you remember which one I'm talking about. And then people come in and say, hey, we comply with all these standards here and all this good stuff here. And you know what that means in terms of threat model? Not a lot. Because yeah, compliance is great and there's a lot of stuff around compliance. You guys probably know compliance way better than I do. But you know what? The devil lives in the places between the compliance questions. You know what I'm talking about? So threat modeling looks at finding and fixing design issues. We want to find where things have been, where the glue is breaking. Next. Then we value people and collaboration over processes, methodologies, and tools. And that means that, let me be clear, there are some great tools out there that help you build a threat model. They do not threat model for you. Why? Because threat modeling is, at its heart, a conceptual process. You are going to think about what you're seeing. You are going to think about what you're doing. You're going to imagine things that could go wrong. If you could formalize a system, the modeling of a system, up to the detail that it could by itself figure out those things, then you might as well just go and write the system, because you are basically using a description language to write the thing that you are actually modeling. So we do prefer people talking and people discussing and people discovering things together over just throwing everything into a tool, clicking a button, getting a report, and working on that report. Next. The journey of understanding over a security or privacy snapshot. Your system will change over time because the market demands it, because technology demands it, because systems demand it. That's the life cycle of a system. From the moment that it's designed to the moment that it's taken off from a service, that thing is going to change. If it doesn't change, then its environment is going to change. The things that go around, the things that talk to it are going to change. So what yesterday could not be a threat, today, because things have changed, might be. So you have to constantly look at that system as it progresses, as it changes, instead of just taking a security or a privacy snapshot and saying, that's it. That's my point in time thing. Today, this thing is secure. I'm done. Let's go. Okay. Next one. Doing threat modeling over talking about it. Many times we have seen people who, for lack of a better word, are scared of threat modeling. Will I do it right? Will I do it sufficiently? Is it going to take a lot of time? Do I know my system enough to threat model it? Do I know threats enough? Do I know how to model the thing enough? And then they spend time and time and time and time. We're going to do it this way, and we're going to do it this way, and we're going to use black pencils and blue whatevers. And they don't get to doing the actual threat model. So you know what? You're going to see later on, it's a journey, it's an evolution. Start small, start with one process, nothing more. Start there and then evolve. But do it. Just freaking go and do it. Next one. Continuous refinement. That's what I was talking about, the evolution over a single delivery. Now, this takes your system is going to change and turns it into its head. You are going to change. The more you threat model, the better you get at threat modeling. The better you get at threat modeling, the better you get at eliciting threats. So things that you didn't see yesterday on the exact same system, you are going to see tomorrow. So do your threat model. Assume, as Matt said, it's not perfect, because believe me, it's probably not going to be. But go back to it tomorrow or next week or next month or next sprint or next release. But go back to it. Don't do the threat model, put it on a desk and forget about it. Because you are going to learn more stuff. So apply that stuff that you learned onto the next iteration of the threat model. Regular and often, exactly. And early. Early, regular, and often. Like going to the restroom. Yeah. Next one. So now we move from the values to the principles, of which we have 4. So 5 principles. No, 5 values, 4 principles. Look at the yellow big words. Those are the keys for each one of the principles. So instead of reading each one of them, I am going to talk to you about the yellow words. So improve, meaning that's journey. Okay, the best use of the threat modeling is to improve the security. It's not going to be your security, it's not going to answer all your questions about security, but it's going to improve whatever posture you are in. Meaning, if yesterday you didn't have a threat model, today you have, bam, you just improved your posture. Good for you. Align. You don't do it in a vacuum. The threat model has to live and exist and happen inside the culture of the organization it happens into. You guys probably already heard that one. How does it go? Every system in the end mimics the organization that it's developed in, or something like that. I'm paraphrasing. But the threat model also has to adapt to that organization. If you try to get a methodology, parachute it from the top and say, hey, this is the brightest, shiniest thing, but that methodology doesn't fit the organization that it's going to be used on, you're going to have attrition. You're going to have people saying, I can't do it. I don't want to do it. If you tell me to do a thorough threat model, I probably won't, because it's not the way that I think about threat models, right? So you have to align, and You have to be ready for changes. You have to work together with those changes. Meaningful. The important thing of a threat model, okay? If you do the whole thing and you come out with a bunch of threats that are just like a shopping list, oh, you have to take care of cross-site scripting. Awesome. I didn't know that before. Now I do. Wow. Those were great 52 hours that we spent to get to this. The result has to be meaningful for you. If it isn't, you did something wrong or you just wasted time. So when you are working on a threat model, try to steer it gently, but surely, to a point where things are going to be meaningful for you. And then dialogue. Dialogue is so freaking important with threat modeling, okay? And an example that I always go back to is that conference room that you have the top chief architect in front of it in the whiteboard saying our system does this and doesn't talk to this and doesn't. And then the junior programmer, the guy that just joined like 3 months ago, at the end of the table eating his hamburger, stops eating and says, yeah, that's how it was designed. We had a problem with the framework. We had to do it in a different way. And then there is what I call an eureka moment. That small piece of dialogue just brought up something that otherwise would be hidden because the chief security, whatever, trusts his design. He says, I designed it to say A, B, C. But he is not up to the details of the framework. And the guy that actually is with his hands in the grease says, hey, I can't do A, B, C with this framework. I had to change it. So things happen. Oops, right? So you have to have this dialogue. You have to document the understandings that you get from from that dialogue. And that becomes part of the threat model.
And I'll add to that dialogue is critical, even if you don't end up with a diagram, or you don't end up with a list of threats, or you don't end up with a complete list of threats. You know, that conversation that you have about a system and what it does, and the stakeholders that you have in those discussions is key, right? You may have somebody in customer support, or somebody in technical documentation, or somebody in QA who's part of the conversation, like, it does what? It has it how? Are you sure? And then this conversation that ensues. And it really gets people on the same page. So yes, it's meant to find security concerns. Yes, it's meant to drive the risk discussion. But really, it does provide interaction between team members. And that's key.
And I like to think that the dialogue actually ties the whole thing up, because by having this dialogue the way that Matt just described, at the end of the day, what you get is something that's meaningful, something that's aligned with what actually is happening in your organization, instead of that diagram that you have in the sky, and something that just improved your security posture, because people now know more than they did. Perhaps not more about threats, but about the system. So tomorrow they'll find other threats, but today they already know more about the system than they did before. Okay, so the dialogue here, I think, is the key. Next, patterns. This five. We had fun with this 5. Why? Because to me personally, it was fun to see that the things that I observed, both the patterns and the anti-patterns, all over like my last 10 years doing this stuff, were things that other people were also seeing. So it wasn't me. It was the world. It's the way the things are, and that's cool. So systemic approach, okay? You have to apply knowledge in a structured way. I call this one the don't throw spaghetti on the wall. Sometimes you have to, most times you shouldn't. Meaning, if you know something, apply it in a way that makes sense. Apply it in a way that you can reapply it the same way, just in order to make sure that you covered all your bases. So if you are, I don't know, using the MITRE ATT&CK matrix to cover all your web stuff, I'm just talking out of my ears, and that's your way of doing it, then tomorrow, do it again same way. Of course, update the matrix if it's been updated. Of course, update it with your own knowledge, but use that as the base of things, right? So that you are sure that you are covering all your bases and you're not forgetting anything. Informed creativity. Informed creativity means it's not only hey, you know what? I've been doing threat modeling for 25 years. I know everything about threat modeling, and I have my thing, and I'm going to do my thing, and you guys are going to pay me a lot of money per hour, and it's going to be awesome for me. Actually have a methodology. Use that. Inform your creativity. Use the things that you think out of the box, inform them with the things in the box. Don't just leave out of the box. Leave in the box as well. Complement one with the other. I cannot say that word, so many viewpoints. Many viewpoints mean that, as we said in the dialogue example, everybody has something to offer. As Matt reminded us, QA is usually like the last guys in the line, right? Nobody's interested in what QA wants to say. They're just those guys that test the stuff that we put out, right? But actually, they have some very interesting views on how things break, because usually they break on their hands. So they know how fragile things are. They can answer the question, what could possibly go wrong, very well many times, because they actually saw those things going wrong. So not keeping to the architects and to the developers and actually asking people, having people with other point of views, with a diverse point of view, come in and join the threat modeling exercise is invaluable. Okay, you want as many of those point of views out there. Useful toolkit. You use tools that improve productivity, not that hinder it. So adjust your tools to your process, not your process to your tools. And that's a discussion that Matt and I have in the book many times. There are tools out there that can help you with the dialogue, that can help you with the consensus of what is it that we are building. There are tools out there that can point at different schemas of threats, things that you would think about. Can it possibly go wrong this way? By all means, use those tools, but don't let the tools limit you. It's the other side again of the informed creativity. Get out of the box of the tools. A tool that improves productivity. Nowadays that we are all remote, and if you guys have interest on this, Adam Shostak has many presentations on the subject. The threat modeling remote is more difficult. It is more difficult. So there are tools, for example, I don't want to use the, okay, there are some video conferencing systems out there that offer whiteboards to work with. Perhaps that's a tool that you want to use. That's something that's going to help your productivity when threat modeling. Perhaps, I don't know, you can use a document that everybody writes on at the same time and everybody can see how the thing changed. That kind of thing. It's not a threat modeling tool, but it's something that certainly will help you to produce better threat models in the reality that we live today. And then theory into practice, okay? By all means, study the methodologies, find one that might work for you, and change it. Do your own thing. Perhaps, I don't know, perhaps, let's take CTM, for example. Perhaps you don't want to threat model every story. Perhaps you want to threat model every sprint. See what came out and threat model just that. Change it, go for it. Perhaps you don't want to use the if this then that list that looks at principles. You want to use one that looks for web stuff. Create your list, go for it. But don't be constrained by the methodologies. Find one that looks good enough for you, try it a couple of times, change it. Feel free to go forward with it. Next.
So, Izar, are you okay if I just do the anti-patterns? We have 4 of them, and well, I'll breeze through them because I know people are dropping like flies. So,
go for it.
Oh, well, first is a question. So, threats can be real or imaginary. Yeah, like that's a good one. I'll let Izar probably try and put that into the chat while we go through some of the.
Yeah, go for it.
All right, so anti-patterns. So with the 4. So hero threat modeler, right? Anyone can threat model, right? The important part here is that you're not reliant on, you should not rely on having a security expert claim to be the expert and be the sole expert when it comes to threat modeling. Anyone can do threat modeling. Everyone does threat modeling. We talked about it in the very first chapter of the book, where if you are crossing the street or you're making any decision that may affect your personal safety, you're doing threat modeling, right? anyone can do a threat model. So don't rely on having somebody come and say, I'm the superhero and I'm going to make this happen. And oh, don't worry about it. You don't need to worry about the details. So ignore the man behind the curtain. So really, anybody can do threat modeling. Really, anybody can do threat modeling, right? And so that's kind of pattern number one. Number two, admiration for the problem. Beware of analysis paralysis, right? Find solutions. Does anyone see a solution in this picture? I hope so. And so you want to be aware of we want to be aware and be careful of getting into the trap of continuing to analyze and analyze and analyze and not reaching those goals, reaching those outcomes that we find of value. Right? We can always subdivide and decompose a system and keep analyzing and analyzing and analyzing. But at some point there's a lag. You're gonna stop getting value for the energy you put in. Right? And so we want to avoid that, right? You don't want to get in that trap, and that's what this anti-pattern was really calling out. Tendency to overfocus, similar problem, right? We want to be careful about getting in the trap of getting stuck on the things that don't matter, right? It's not to say that adversaries and assets don't matter. It's just that there may be other things that matter more, right? And so understanding a threat landscape or the attack surface or how this impacts the functionality of our product and what customer value that's going to have may be more valuable than which nation state do we think is going to come after us tomorrow, right? Because most companies, nation states are not their problem, right? And so don't get hung up on that. A lot of people like to talk about assets, right? The crown jewels, right? Well, that's great. That's sort of the outcome, but not necessarily what you want to focus on when you're doing threat modeling. You want to focus on those attack surfaces or how the modules are put together, or does everything stitch together, just right so that you can have a defensible architecture. That's potentially more important. So be careful about focusing on things that will give you, diminishing value for your effort. And then lastly, perfect representation, right? There's no single ideal view. We proved that earlier, right? Here are three, just to bring back our examples, here's three views of the same system, right? And so there is no perfect representation. If you continue and going back to looking at tendency to overfocus and admiration for the problem as well, and especially somebody who you're paying to do, to bring in to do this and be the hero, may guide you towards making things perfect. But that's okay if you're not, right? Perfect representation, it is okay to reach a point where you can make decisions that are meaningful and get value out of it without going too far. And so these are the goals of these 4 anti-patterns, is to help people avoid the traps that will make threat modeling less value, provide less value, and be therefore less meaningful to them. And I think with that, we've reached the natural stopping point.